Welcome to the lesson Ice and Rain Protection. The aircraft is fitted with ice protection systems to prevent the formation of ice. Airframe ice protection is by hot air from each engine for wing leading edges, tailplane leading edges. Other ice protection is by electrical heating for pitot heads, front static vent plates, AOA vanes, Q-Field pitot head, windscreens A and B, and TAT probes. Each A windscreen is provided with 2-speed wiper and a manually operated screen wash. An ice detector mounted on the nose provides automatic warning of ice accretion. The ice detector is controlled by the ice detect switch on the ice protection panel. The switch is normally on and is covered to prevent its being selected off accidentally. The ice detector is comprised of an AC motor driving a serrated rotor next to a fixed knife edge cutter. In icing conditions, the cutter shaves the ice which forms on the serrated rotor. This action produces a torque reaction on the AC motor, which illuminates ice detected on the central warning panel. The annunciator will remain lit for 60 seconds or until the aircraft is out of icing conditions. Wing ice protection is provided by 2 separate systems: outer wing anti-icing and inner wing de-icing. The complete wing leading edge is anti-iced by hot air normally supplied from the outer engines 1 and 4. Additional ice protection is provided for the inner section of the wing only, which is de-iced by hot air normally supplied from the inner engines 2 and 3. If an air supply is unserviceable, air can be supplied to either system from an adjacent engine. Exhaust air is ducted over through vents at the wing tips across the aileron horn. Outer wing anti-icing is used whenever ice forms on the airframe to keep the leading edges clear of ice. Inner wing de-icing is used during holding or after the aircraft leaves icing conditions to remove built-up ice from the inner section of the wing. Each system has a control switch on the ice protection panel, each controlling a pair of valves. The valves can only be opened in flight, and each has a not in position selected annunciator. Operation of either outer wing anti-icing or inner wing de-icing is confirmed by wing tail anti-ice on the central status panel. If an approach is made in icing conditions, inner wing de-icing is used to ensure removal of all ice from the inner wing. If it is not, wing not de-iced illuminates on the central warning panel when flaps are selected. This is to remind the crew that insufficient ice protection is being used. If the temperature of an engine air supply is low when outer wing anti-ice or inner wing de-ice are in use, air low temp illuminates on the ice protection panel. Engine air fault also illuminates to identify which engine air supply is affected. Engine air fault will not illuminate if the engine air valve is selected off. The leading edge of the tailplane is anti-iced by hot air from the two bleed air ducts at the rear of the spine. Hot air is supplied via two valves, one in each duct. Downstream of the valves, the ducts merge into one, supplying the leading edge of the tailplane. Exhaust air is ducted overboard through a fin cap vent. The system is inhibited when the aircraft is on ground. A tail anti-ice switch on the ice protection panel controls both valves, and each valve has a not in position selected annunciator. Operation of tail anti-ice is confirmed by wing tail anti-ice on. This annunciator confirms the operation on any of the three airframe ice protection systems. The pitot heads, static plates, TAT probes, and airflow sensor vanes are fitted with electrically heated elements to prevent ice formation. There are three pitot heads mounted on the forward fuselage, the captain's on the left-hand side, the first officer's on the right-hand side. An auxiliary pitot head is fitted on the right-hand side just below the first officer's. A Q-pod pitot head supplies the control field system and is mounted on the underside of the forward fuselage. Static plates are mounted on each side immediately below the windscreen B panels. Airflow sensor vanes and TAT probes are mounted on each side of the forward fuselage. Three switches labeled left pitot heaters, right pitot heaters and right vane, and auxiliary and left vane control power to the pitot heaters and airflow sensor vane heaters. The Q-pod pitot head, TAT probes, and static plates are heated automatically when the aircraft is in flight. Failure of any pitot heater, airflow sensor vane heater, or the Q-pod pitot heater is indicated on the ice protection panel. There is no failure indication for a static plate or TAT probe heater. The A and B windscreen panels are electrically heated to prevent the formation of ice and mist on them, and to improve their resistance to bird strike. Heating of the left and right A and B panels is controlled from the left and right screen heat switches on the overhead ice protection panel. When the aircraft is on ground, the two A panels are heated at 1/3 power. Full power is applied automatically in flight. The two B panels are always heated at full power. When electrical power is reduced to the essential level, the captain's A panel is heated at 1/3 power. The captain's B panel and both of the first officer's panels are not heated. Each screen is fitted with one normal and two overheat temperature sensors. The normal sensor regulates screen temperature. If the normal sensor fails, screen temperature rises. When either overheat sensor operates, power to the windscreen is disconnected and left or right screen high temp illuminates. When the panel cools down, the heating supplies are restored to the windscreen panel and its temperature is regulated to a higher level than normal. The fault warning remain illuminated until reset by cycling the appropriate screen heat switch. If screen heat is not selected on at any time, screen heat selected off illuminates on the central status panel. Windscreen wipers are fitted to each A panel. They have dedicated control switches located on the lower overhead panel. The wipers have two operating speeds, fast and slow. The external surfaces of the two A windscreen panels can be cleaned using the windscreen wash system. Pressing the left or right screen wash buttons on the lower overhead panel will direct fluid onto the screens. The fluid is stored in a reservoir in the electric equipment bay. A rain repellent system is fitted on the aircraft, but because of the harmful effects of the fluid, the system is normally disabled. The aircraft must be clear of all snow, ice, and frost before takeoff. However, an exception is made where frost to a limited depth in certain areas may be allowed as detailed in the manufacturer's operating manual. This is an aircraft limitation. The ice detector cover must be removed and the ice detector inspected for general condition. Before commencing the external checks, the ice detector may be switched on in order to observe rotation of the serrated rotor. The condition of the windscreen wipers and screen wash rain repellent heads must be checked. After AC power has been supplied to the bus bars, the screen heat and pitot and vane heaters must be checked off. This is confirmed by the 5 heater fail caption. The Q-Feel heater fail caption is not lit because power is not supplied to the heater on the ground. Screen heat selected off should be lit on the master warning system. Outer wing anti-ice, inner wing de-ice, tail anti-ice, and ice detect should all be checked off. The associated wing and tail ice protection valve indications should all be checked out. After engine start, all the heater switches and de-ice detector are selected on, the screen heat selected off, and all the captions on the ice protection panel should now extinguish. Icing conditions exist when the indicated outside air temperature is 10 degrees Celsius or below, and visible moisture of any kind is present. Visible moisture includes clouds, fog with a visibility of less than 1.6 kilometers, rain, snow, sleet, and ice crystals. This is an aircraft limitation. Ice may not necessarily form on the airframe during flight in icing conditions. If it does, it will be visible on the windscreen wipers and indicated by ice detected on the master warning system.